I'm Anil Kumar, and in this video, I'll discuss most of the things which you need to know about inverse functions. Let us consider this box to be a function. So we'll normally just say this is like f, right? A function. Now, whenever there is a function, we have some input and some output. Normally, we'll write inputs in terms of x and the outputs in terms of the y values, right? We also write this y value as f of x, correct? Let me consider function operation where we are doing y equals to, let's say f of x equals to 2x plus 4. It really means that if I send in an input, let us say 1, in that case 1 gets multiplied by 2 and then we add 4, the output will be 2 plus 4, 6. If I send in input 2, then the output will be 2 times 2, 4, 4 plus 4 as 8. For 3, it will be 6 plus 4, 10. If I send some negative numbers in, let us say minus 2, then the input will be minus 4 plus 4 as 0. If input is minus 1, the output will be minus 2 plus 4, which is 2. If input is 0, then the output will be 4. So basically what is happening here is that all the inputs are being operated by the function, resulting into an output. Now this set of inputs is called the domain, and the outputs will be called as range. So that is about the function. Now when we talk about inverse function, in that case, inverse function we normally represent by f inverse. The process is kind of reversed. That is to say, we'll send an input from this side, which was the output. Let us say if I feed in 6 through the box, then what I get here as an output should be 1. Do you see that? So we get just the reverse of this. So that is the inverse function. It performs the operation so that what was done by the function reverses, and you get what you fed in. That's the whole idea. Now, inverse function I could easily get from the function itself by rearranging. We will use a technique which is like getting the inverse from words. The operation here is times 2 plus or add 4. The inverse will be written as, on x, whatever we feed in will take away 4. We'll do just the reverse. So it will be x minus 4, and then earlier we multiplied, this time we'll divide. So if we do the reverse operation, we actually get our inverse function. Let's check. If I feed in 6, 6 minus 4 is 2, 2 divided by 2 is 1. Do you see that? If I feed in 8, 8 minus 4 is 4, 4 divided by 2 is 2. Similarly, if I feed in 0, 0 minus 4 is minus 4 divided by 2 will be minus 2. Do you see that? So what you have seen here is that for each input, we get the corresponding output, which was earlier the input. Do you see that? The whole operation has been reversed. So that is what the inverse function does. So for inverse function, earlier range becomes the domain. Now this becomes the domain. Do you see that? And that becomes the range. So range and domain also flips. So that is the very basic concept. So it is important to note that we can always get inverse of a function by doing the operation in the reverse order, domain of the function and range of the function becomes range and domain of the inverse function. They like kind of change, right? Now, I'll take two examples here to continue further, and we'll talk about inverse of two very important functions. The first one here is, let us say that the function f of x is equal to square root of x. In that case, what is inverse of this function? Let's say that's a question for you. You can actually pause the video, answer this question, and then continue with my video. Well, another algebraic method to find inverse which you have learned is swap x and y. So what we are given here is y equals to square root of x. To find inverse, we need to find inverse. We'll swap x and y. So we could write this as x equals to square root of y. Now we need to solve for y, right? So we say solve y. You can square both sides. Once you square, you get x squared equals to y. And then you can write f inverse of x is equal to x squared. Correct? So that is what you get. However, this is not the correct answer. There is an error here. Whenever you square, you tend to make an error. Now, can you point out what is the error here? This is very important, and that is why I had extended this video. Now, important thing to understand here is, what is the domain and range of square root of x? Now, the domain for square root of x is x greater than or equal to 0, and the range is also y greater than or equal to 0. Is that okay? Now, when you do inverse of a function, domain and range swap. So range becomes the domain. So in this case, we should have written that the domain of this function should be x greater than or equal to 0, right? And range should be y greater than or equal to 0. This is after swapping we get similar values, so don't get confused. We are not writing the same thing, we have swapped. That y, that this value is here, correct? And this value we have written here, swapped and written. Do you understand? Now this is important to understand. You will soon realize how. If I sketch it, let me sketch it at this place. Square root x function is kind of like this, right? But if you say that inverse is x squared, you're saying that the inverse is kind of like this. You can easily see that inverse of this should not be the whole parabola. It should only be the right side of the parabola, right? It should only be that part of the parabola. Is it okay? Not this one. Now that you can get only if you put this condition, the domain is x greater than or equal to 0. If domain is restricted, then range automatically, well, it is in this case greater than or equal to 0. However, it is important to note that when you do this square, you should include domain greater than or equal to 0. Only then inverse of square root of x will be x squared restricted to domain greater than or equal to 0, right? So I hope that is important point of view which is taken care of. Now let me give you another example here. Let us say we have function g of x equals to x squared. Now what is the domain range for this? Now domain for this is, let me write, domain for this function is x greater than or equal to, x belongs to real, let me rewrite. So here, domain of this function is x belongs to real numbers, and the range is y is greater than or equal to 0, right? Of course, all real numbers. Now, if I have to find inverse of this function, then what do? I write this as y equals to x square, swap, which is x equals to y square, and then solve for y, right? We are doing the same step. When you solve for y, you have to do square root of x, right? And whenever you do square root of x, you have to do plus and minus. Do you see that? Plus and minus. Now, not just square root, right? So, as you can see here, if I sketch this function, let us say if I sketch the function x square, it is kind of like this, right? So the inverse of this function will be this, where this is square root of x plus and this is square root of x with a negative sign, right? So you get y as square root of x plus and minus. So inverse of this function is not only square root of x, it is square root of x with plus and minus sign, correct? It matches with your domain and range. The range, which was greater than or equal to 0, becomes the domain here. So here, what we note here is that the domain is x belongs to real numbers. We are swapping this, right? X is greater than or equal to 0, right? Normally we put curly brackets to make it a set of numbers, right? So you can make curly brackets everywhere. And so that y, which is greater than or equal to 0, becomes x value. You can see from here, the domain of square root function plus and minus, it is not really a function. So at times we don't even write x, we just write f inverse is x belongs to real numbers where x is greater than or equal to 0. And as you can see, range in this case is y belongs to real numbers, right? There's no restriction. Since in x squared, domain has no restriction. Do you see the swapping? It's very clear with this example. Here it was not that clear. I hope now you understand that whenever you find an inverse function, then the domain and range also swaps. I'm Anil Kumar and I hope that helps. You can always share and subscribe to my videos. Feel free to post questions, and if you like, you can put some likes. Thank you and all the best.